Today we are going to be discussing arithmetic gradients and answering this question on the future value of an arithmetic progression. So what is an arithmetic gradient? Basically, it's a series of flows that increases or decreases by a constant or a fixed amount for a period of time. So previously we talked about annuities where we make an equal payment every time. But with an arithmetic gradient, we would have a certain amount to start with, and then that amount would increase or decrease by a certain amount every single month or year or quarter or however often we're paying it back. So in this example, it says Beth plans to deposit $1,000 in a financial institution at the end of each month and will increase it by $50 each month. Right? So first month, she's going to do $1,000, then it'll be $1,050 the next month, then $1,100, then $1,150, then $1,200, and so on. So the point is, every time she makes a deposit, it goes up by the same dollar amount of $50. How much will she have saved after 1 year if the interest rate is 8% annually, compounded monthly? Okay, so here's the future value equation up here for gradients. So first thing we need to do is put in what we know. In this case, our A value is $1,000, so that's a little bit of a thick line there. Let's try that again. A is equal to $1,000, since that's the starting annuity amount. Now we have I, the interest rate, which is 8% per year. And then, of course, we need to divide that by the number of compounding periods per year, which is 12, to get the equivalent monthly rate. So that is going to be 0.006 repeating. Okay, next we need to figure out n, the number of compounding periods. Well, they want to know how much will she have saved after 1 year. So therefore, that will mean 12 deposits and 12 compounding periods. So in this case, n is equal to 12 months. So 12. And then last but not least, we have the gradient number, right? So that's how much are we going up by every time, and that is by $50. So therefore, G for gradient is going to be equal to, well, that's not a great G. Let's try that again. $50. And now we just need to plug that into the equation up here. Okay, so future value is equal to A, so $1,000, times 1 plus I to the power n, so that's going to be 1.006, repeating, to the power of 12 minus 1, all over 0.006, repeating, and then plus g over I, so plus 50 over 0.006, repeating. And then here we have 1 plus I to the power n again, so 1.006 repeating to the power of 12 minus 1. Actually, let's move down a little bit so you can see that. Okay, and then over I, which is 0.006 repeating, and then minus n. Which is 12. And so there we go. All right, so next what I need to do is I need to figure all this out. So I would strongly advise figuring out each part individually, and then we'll add them together at the very last step. So let's first talk about finding this entire first part here using our calculator. So I'm going to punch into my calculator 1.006 repeating, and then power of 12 equals minus 1 equals divided by 0.006 repeating equals times 1,000 equals. So that is going to give me $12,449.93 for the first part there. And then we're going to do the same with the second part here. So first we have 1.006 repeating to the power of 12 equals minus 1 equals divided by 0.006 repeating equals minus 12 equals times 50 equals divided by 0.006 repeating equals. And that gives me $3,374.44. All right, and now we just need to add up those two numbers and see what we get. All right, so we're going to get, if we add those up, that the future value is $15,824.37. So therefore, in 1 year, if Beth sticks to this plan, she will have $15,824.37. As always, if you have any questions, please feel free to leave those in the comment section, and we'll see you for the next one.